So this says to simplify the expression. So you've got this 5x minus x plus 9x. Now the first thing I need you to know is that when you have a variable without a number in front of it, it's a 1. So this really becomes 5x minus 1x plus 9x. And thinking about, please excuse my dear Aunt Sally, we have no parentheses, we have no exponents. We don't really have any multiplication or division because we're supposed to add and combine these like terms. So we do have addition and subtraction, and we're going to do it left to right. So this says 5x minus 1x, that gives us 4x. And then we're going to bring down the plus 9x. Now we have 4x plus 9x, that gives us 13x, and that is our answer, 13x. Now a lot of students want to do something that, I don't know, I guess it might make sense, but it's wrong. A lot of students might want to put 4x plus 9x equals 13x squared because they see an x and an x, and so they want to put a 2 there or something. Totally wrong, totally not allowed. So the answer, I want you to think of it like apples. 4 apples plus 9 apples equals 13 apples. Think of it as a label. All right, simplify the expression, and I need you to just ignore that little symbol there. All right, so it's negative 8 plus 7z plus 2 minus 2z. And so what we want to do is first we want to identify the like terms. Here's just a plain old constant, and here's a plain old constant. So those are like terms. And then here's a variable, and here's a variable. And those are like terms because they're both z's. All right. Now I'm going to use the commutative property, and I'm going to put them all next to each other, like terms next to each other. So you'll notice I put these guys next to each other, and then I've got minus 8 plus 2. All right, so you can see I used the commutative property and rearranged where everything, the order of everything. And now we've got this 7z, or positive 7z, minus 2. Well, 7 minus 2, that's 5. 5z. And then right here, I want you to, I want you to think of this as negative 8 plus 2. Well, negative 8 plus 2 gives us negative 6. And that's our answer right there, is negative 6. So the answer becomes 5z minus 6. And that's what you're going to put in your little box. All right, so we're being asked to simplify this expression, and you see some parentheses. Now, the thing I want you to notice is this 2 in front of, well, it's actually a negative 2, in front of the parentheses means multiply. And when you have a number in front of a quantity like this, that means you're actually going to have to do the distributive property. So you're going to have a negative 2 times the 2y. Then you're going to have the negative 2 times, and remember, this is a negative 3x. And so this becomes, so let's see, negative 2 times 2y. So negative 2 times 2y becomes negative 4y. And then negative 2 times negative 3x. So negative times a negative. So the answer is going to be positive. And it's going to be positive 6x. So it's going to be positive 6x. And then this minus y, we just kind of bring it straight down. We're not quite ready for it yet. And remember, if you have a variable with no number in front of it, that means it's a, let's see, it's a 1 right there. So it's going to be a negative 1y. And we have like terms right here, and then we have this guy who's the oddball out. So if I wanted to arrange the order to put like terms next to each other, I'm going to have negative 4y minus 1y plus 6x. And then I can see that, okay, now this is going to be tricky. Negative 4y minus 1y. I'm going to go down here on scratch paper. I'm going to ignore the y's for a second. What is negative 4 minus 1? And a lot of students say the answer is negative 3, and that's wrong. It's really negative 5. Now, why is it negative 5? Because the rule for subtracting is the first number stays the same, the minus sign becomes a plus sign, and this, what used to be a 1, becomes a negative 1. So negative 4 plus negative 1 becomes negative 5. So over here, negative 4y minus 1y becomes negative 5y. And then the 6x, there's nothing to do, so we just bring it straight down, and that is our answer. Negative 5y plus 6. Negative 5y plus 6x. Sorry, forgot the x. More of the same. Simplify the expression. So we've got negative 3y minus, and I'm going to put a little gap there, and you'll see why in a second. When you have just a minus in front of the parenthesis, I want you to think of it as a 1. All right. And so we've got a distributive property right here, because when you have something being multiplied by a quantity, that means you've got the distributive property. And we're going to take that negative 1 and we're going to distribute it to the 8y, and we're going to distribute it to the positive 1 right here. So we end up with that negative 3y just sits there, doesn't do anything quite yet. Now let's take a look at this. Negative 1 times 8y, that becomes negative 8y. And then you've got negative 1 times positive 1, that gives you negative 1. And look at that. Our like terms are already next door to each other. So you've got negative 3y minus 8y. So that's going to become negative 11y. So that's this piece right here. And then the minus 1, because he doesn't have any like terms. So he just comes straight back down. Now, so the answer is negative 11y minus 1. Now, a lot of students are going to go, but whoa. How did you get the negative 11? Well, let's take a look at this negative 3 minus 8. I'm going to ignore the y's for a second. So negative 3 minus 8. And the rule is the first number stays the same. The minus sign becomes a plus sign. And the second number, which in this case is an 8, becomes a negative 8. And so now you have negative 3 plus negative 8 becomes negative 11. And that's how we got the answer of negative 11y. All right, here we've got to simplify this expression, and it's got fractions, but there's nothing to be afraid of. It's not hard. It's going to be straightforward. It's going to be easy. It's going to be a piece of cake. So first thing I want you to notice is we've got two instances of the distributive property. We've got 3/5 being multiplied by x and 3/5 being multiplied by positive y. And then we have negative 1/5 times x, and we have negative 1/5 being multiplied by negative 1. So we've got a lot of distributive property, and we have to keep those signs straightened. So 3/5 times x, everything's positive, so that becomes 3/5 x. Now here it's 3/5 times positive y, so that becomes 3/5 y. It's positive 3/5 y, because this number is positive, this number is positive, so everything is going to be positive 3/5 y. Now over here, we've got a negative 1/5 being multiplied by x, so that becomes negative 1/5 x. And then we've got negative 1/5 being multiplied by negative 1. Negative times negative, it's going to be a positive, so it's going to be positive 1/5. And now we have to simplify, and so we're going to combine our like terms. So I'm going to see if I can shave a little work off here. Okay, I've got 3/5 x and minus 1/5 x. So combining those two terms, I get 2/5 x. This guy is a loner. He has no like terms, so we're just going to put plus 3/5 y. And then similarly, this guy's a loner. He has no like terms, so I'm going to put just plus 1/5. And that is our final answer, 2/5 x plus 3/5 y plus 1/5. And that goes up there. More of the same. We've got 3a plus 8b minus 3a minus b. All right, so the first thing I'm going to do is I want us to recognize what are the like terms. So you've got a like term here, and then you've got a like term here. All right, so if we wanted to, we don't have to, but I'm going to, we could use the commutative property to rearrange so that our like terms are next door to each other. Now 3a minus 3a, that's 0a. And then, let's see here, we've got positive 8b minus b. And remember, if there's no number, it's a 1. So what is positive 8 minus 1? Well, it's going to be 7. So that's going to be positive 7b. Now, technically, this is your answer, but being more precise, we know that 0 times anything is 0. So really, this whole thing just kind of goes away because that's worth nothing. It's a 0. So our answer is simply 7b. 7b. All right, and so now we have 4m plus 5n plus 9m plus 7n. And first thing I'm going to do is I'm going to identify our like terms. So those guys are like terms, and these guys are like terms. And I'm going to do a little bit of combining of steps. Now, this 4m, since there is no symbol in front of it, it means it's positive. So you have 4m plus 9m, that gives you 13m. Then you have 5n and 7n. These are positives. So positive 5n plus 7n, that gives you 12n, and that is our final answer. Simplifying more expressions, only this time it looks like a fraction. So you've got 7/10 y over 7/10. Now the thing I want you to notice is I want you to remember this means these two guys are being multiplied. So it really means 0.7 times y. All right, and then down here you've got 0.7. Now 0.7 over 0.7, if we want to, we can kind of slightly, I don't know, reorganize how we write it. This right here is 1. You know how like 5 over 5 is equal to 1, or 9 over 9 is equal to 1? Well, anything on top of itself is equal to 1. So right here, 0.7 on top of 0.7, that's equal to 1, y. So the answer is 1y. But you don't really need to put the 1, so your answer right here can just be y. I think it would accept it if you put 1y. That would also work, but y is the simplest way to write your answer. All right, so again, we're going to simplify, and we have another fraction. So we have 15z over z. And I want you to remember that 15z, those two are being multiplied by one another, and then the z down in the denominator. And remember, this guy right here is equal to 1. So that's really equal to 15 times 1, which is 15. Now, a lot of textbooks say, well, the z's cancel out, and you can kind of cancel these out, and that's how you get 15. But really, I want you to think of it my way, which is z over z is equal to 1. Because remember, anything on top of itself, 5 over 5 is equal to 1. 9 over 9 is equal to 1. Well, that means z over z is equal to 1. Anything on top of itself is always going to be equal to 1, because that means z divided by z equals 1. Anything divided by itself is always 1. And so z divided by z is 1. And so the answer is 15. And so you're going to put the answer right there, 15. And our last problem now, there's a tricky one. This is going to be a little bit different because we don't have just a term in the numerator. We actually have an expression. We've got two terms up there, and they're each being divided by the 5. So I want you to think of this as 10. Let's see, I want to shrink this a little bit there. And I'm going to move that there. Okay, I want you to think of this as 10x divided by 5 minus 25 divided by 5. So what is this 10x divided by 5? Well, that 10, you can think of it as 2 times 5 times x over 5. And the 25, whoa, you can think of it as 5 times 5 divided by 5. And why did we do it that way? Because what's 5 divided by 5? That's 1. So this becomes 2 times 1 times x minus, and then look at this, 5 divided by 5, that's 1. And so you end up with minus 5 times 1. So really this becomes 2x minus 5. Now a lot of people are going to do the shortcuts, and they're going to say, well, 10 divided by 5 is 2. So you just take the 2 and you just put the x right here. And then 25 divided by 5 is 5. And so you get 2x minus 5. Yes, and that's a shortcut. I was trying to show you all the steps so that it kind of makes sense. It's going to need to make sense down the road. And so the answer is 2x minus 5 right here.